Hi all. Today we'll discuss Thevenin's theorem. So Thevenin's theorem states that a linear and bidirectional two-terminal network can be replaced by an equivalent network consisting of a voltage source VTH connected in series with a resistance RTH, where VTH is nothing but open circuit voltage at the terminals and RTH is input or equivalent resistance at the terminals when the independent sources are turned off. So let us understand this theorem. What does this theorem is telling is that this is a linear circuit having two ports can be replaced by simple circuit like this by finding out VTH and RTH. Okay, so let us understand how that can be done. Okay, for that first we need to find out RTH. How will you calculate RTH? What is the condition for that? We need to turn off independent sources, right? What are the independent sources here? 50 volt source and 3 ampere source, right? So for that turning off them means you have to short circuit this voltage source and open circuit this current source. Open circuit in the sense you just have to remove that. Okay, you just have to remove that current source and short circuit this one, so that you will get these circuits. See, 4 ohm, 4 ohm, and this voltage source is getting short circuited, so just a simple line, and we have removed this current source, and we are left with 5 ohm resistors and 9 ohm resistor, and this is the load resistance RL. We have to remove that, right? At the terminals. Okay, we have to remove that RL. Okay, now we have to find out what is the resistance between these two terminals A, B. So as you can see in the picture, we can conclude that these 4 and 5 ohms are in parallel. Okay, 4 and 5 ohms, 4 ohm is in parallel with 5 ohm plus this 9 ohm, because after finding out the effective resistance, that resistance will be in series with this 9 ohm, right? So I am adding that thing. Okay, so 4 ohm parallel with 5 ohm, I will calculate this one. 4 into 5 divided by 4 plus 5, so plus 9. So finally you will get RTH, that is the resistance between these two terminals AB, nearly equal to 11.2 something. So I have approximately written as 11.2. Now calculating VTH, for that what we have to do? Okay, you just have to remove that load resistance and calculate what is VTH, that is in the sense what is voltage drop across these two terminals now. Okay, so calculating VTH, calculating the voltage across these two is nothing but calculating voltage at this point, right? Because there is no flow of current, because this is open circuited. When the current comes here, it will go completely in this branch, not here, because this is open circuit. Okay, there is no path for that current. So calculating VTH is nothing but calculating the value of VC now. Okay, this point. So calculating voltage at this point is nothing but calculating voltage at this point, right? Because this is just short circuited. This is like just a wire, right? Measuring the voltage at this terminal is nothing but measuring the voltage at this terminal. Okay, or node. Okay, now I am applying nodal analysis and assuming that I1 is flowing in this direction and I2 is flowing in this direction and I3 is moving out of that node. Okay, so what I can write? I1 is entering to this node and I2 is also entering, and I3 is leaving that node. So what I can write? I1 plus I2 is equals to I3. Can I write that? I1 plus I2 is equals to I3. So I have written that. Now we know that I is equals to V by R. So I is, what is V? That is the potential difference, right? So what is the potential difference? 50 minus Vc divided by 4. This is the potential difference. 50 minus Vc divided by resistance is 4 ohm. Okay, now for the second I2, we know that I2 is 3 only, because there is a source, right? 3 ohm 3 amps of source, so 3 I am writing directly. Next I3, what is I3? I3, since there are no current flowing in this direction, what is I3? So this is Vc minus, what is the voltage drop at this in here at this node? That is ground, right? So Vc minus 0 divided by 5. Okay, Vc minus 0 divided by 5. So you can solve for this for Vc. Now I have just solved for Vc and I got 34.4 volts as the output. Okay, so in final, what we can how we can represent, Vth is 34.4 and Rth is 11.2 and the load resistance we are having 6 ohms. Okay, so that's how we can convert this circuit to this circuit. Okay, now let us understand how to implement in the PSpice simulator. Okay, thank you.